Welcome to Mickey Study Circle channel. In this video, we shall see how to do the computer drafting of the orthographic projection of planes using the Solid Edge software. Coming to the problem statement, a rectangular lamina of 35 mm cross 20 mm rests on HP on one of its shorter edges. The lamina is rotated about the edge on which it rests till it appears as a square in the top view. The edge on which the lamina rests is inclined to VP at 30 degrees. Draw the projections of the lamina and find its inclinations with HP. So, looking at the problem statement, we can understand that there is a rectangular lamina measuring 35 cross 20 mm. That is, the longer edge is 35 mm and the shorter edge is 20 mm. And it is resting initially on HP on one of its shorter edges. That is, the edge measuring 20 mm. So, that is the resting condition. Also, this lamina, when rotated with respect to the HP, it is going to appear as a square in the horizontal plane. So, that is, the top view of the second position is going to be a square of side 20 mm. And also it tells that the edge on which it is resting, so initially it is resting on one of its shorter edges measuring 20 mm. So this edge is also inclined to the vertical plane at an angle of 30 degrees. So with this data we are going to do the construction. Also we can make a note here that it is the edge which is inclined to the VP, and since the edge is not going to vary in its length, whether it is HP or VP inclination, so obviously it is a non-beta angle problem. So now we will begin the construction, and we will begin it by doing the XY line of thickness 0.18 mm. So we'll draw a line of any arbitrary length and annotate that line as XY. This is the reference line XY and the planes VP and HP. So now we will draw the top view of the rectangle resting on one of its shorter edges. So the longer edge should measure 35 and the shorter edge shall measure 20 mm as given in the problem statement. We'll complete the rectangle. So using the smart dimension tool, show the shorter edge and the longer edge dimension. And let us annotate the top view of the rectangle. So all the four corners as A, B, C, D. This is corner A, this is corner B, this is corner C, and this is corner D. So this completes the top view of the rectangle lamina resting on one of its shorter edges, AB. So AB is the shorter edge. So we'll always take the reference condition towards the right hand side of the observer. Now we shall draw the front view of this rectangular lamina by drawing the projections from the top view and intersecting it with the reference line. So let us trim this portion of the XY line and draw the front view of the rectangular lamina. So again, the front view will be visible as a straight line. So let us mark it by a line of thickness 0.50 mm. Let us annotate the front view. So the observer is going to look at from here. So for him, corner B is visible first. So B dash, and A dash is not visible. So it is inside the bracket. And here this is corner C dash, which is visible first, and D dash inside the bracket. So this completes the initial position wherein a rectangular lamina is resting on one of its shorter edges. But when coming to the inclination with respect to HP, there is no angle given to us, but it tells that in the top view it is going to appear as a square. So obviously the square should have a side dimension of 20 mm because it is the edge on which it is resting is also inclined to the VP in the next position. So keeping that in mind, we need to draw a square of 20 cross 20 mm. So in the second position, let us draw a square of dimension 20 cross 20 mm. So you can choose any convenient arbitrary distance from the first position and start drawing the top view of the rectangular lamina, which is going to appear as a square of dimension 20 cross 20. Correct? So this is the solution as per the problem statement given to us. So now we'll annotate this square lamina, which is the top view of this rectangular lamina, as ABCD. This is corner A, this is corner B, and this is corner C, and this is corner D. So we do not know the inclination. So to find the inclination, what we will do is we shall draw the projection lines from AB and then CD and extend it. And now we will measure this distance. So obviously this distance will be equal to 35 mm. So what we will do is we'll select the line option, or better, the arc by center point. So we'll go for the arc by center point, and keeping this as the point of reference, let us draw the front view of this, which is going to be the front view of the lamina. So this is the point of intersection. So from here, let me draw an arc of radii 35 mm. So it has to intersect, so that we'll get the point of intersection properly. So from the point of intersection to the point which was considered to draw the arc, let us draw the front view. Or you can just measure this and then rotate this, keeping this as the point of center. Either way it is correct. So now we will just trim this part. So now we will measure the inclination of this with respect to the HP. So it is inclined at an angle of 55 degrees. Now we will annotate the front view. So here it is B dash, A dash, and the corner points in the top is C dash, D dash. So this completes the second position. So here they have one given the inclination with respect to the HP, and we have found out what is the inclination with respect to the HP by the data given to us, which tells that it appears to be a square of dimension 20 cross 20. So now with respect to the VP, they have given us the inclination, but the condition is the edge on which it is resting is inclined to the VP at an angle of 30 degrees. So what we will do is first we shall draw the projection line inclined at an angle of 30 degrees to the VP. So this is the 30-degree line. And now we will select this square lamina along with the annotations. And then we will move this considering the copy is on. So keeping point A as the reference, place the point A on this 30-degree line. And then select the rotate option. First point of rotation, second point of rotation. So just place this lamina and then let us drag it a bit so that it is not making any intersections with the reference line. The projection lines are free. So now we will draw the projection lines from the front view, that is from left to right, and then from top to from bottom to top. So this is the projection line from corner D, and this is the projection line from corner C. So now we will complete the front view of the rectangular lamina when it is inclined at an angle of 30 degrees with respect to the VP. So this is how the rectangular lamina will look. So we will annotate this. So this is the corner C dash, and this is the corner D dash. While this corner marks A dash and this corner marks B dash. Always ensure that the annotations representing the entity in the front view shall always be above the XY line, or they shall always be in the vertical plane. So we will complete the problem by drawing the directions of the projection line using the leader option. It's always a good practice to trim the projection lines of unnecessary length so that it looks neat. So now we'll use the fit option, go to the leader, select the properties and change the color of the arrowhead to black. Click OK, and then we'll start placing the arrowheads. So in most of the cases, the projection lines will be drawn downwards, but here we have used this technique, that is to draw the upwards and then mark this position. So it is better you show this direction. Also, if you just retain this line, that is also okay. It is not an issue. It is just showing that you have extended the projection line to get this view. Okay, so with this, we complete the problem. So to sum up, a rectangular lamina is initially resting on one of its shorter edges, and that shorter edge here is AB, and then it is appearing as a square of dimension 20 cross 20 in its top view when it is inclined with respect to the HP. So we'll draw a square of 20 cross 20 and then find out the inclination of the lamina with respect to the horizontal plane. And next, the edge on which it is resting is also inclined to VP at an angle of 30 degrees. So let us just mark the angle. So this is 30 degrees. So the edge on which it is resting is AB. So this AB is inclined to the VP at an angle of 30 degrees, and this completes the top view of the square lamina. And now it is going to appear as this parallelogram in the front view, that is A dash, B dash, C dash, D dash. So what is the validation? The initial resting edge is AB, and also the final resting condition is A dash, B dash. So with this, we complete the problem of the inclination of rectangular lamina when its inclination with respect to the horizontal plane is not given, but its profile is given, like how it is going to appear in the horizontal plane. Thank you all for watching.